And welcome back to today's lesson, or welcome to today's lessons, I guess I should say. First thing we're going to do here is go over your actual mechanical advantage worksheet, which you got last class. So I'm just going to go through, work the problems, check your work against my work. When you are completed, either make sure it gets submitted online or you will need to turn your paper into the sub. Okay, so let's get going. If we look at this first problem, it says a force of 30 newtons applied to a screwdriver. The screwdriver applies 75 newtons force of lead. So in this case, the screwdriver is being used as a lever. So what we're going to find out is what is the mechanical advantage of using the screwdriver as a lever. As we talked about in class, mechanical advantage and forces, we can simply take the force out and compare that to the force in. So in this case, how much force was the screwdriver able to apply to the lid? And in that case, it was 75 newtons. And then all we simply have to do is we are going to divide that then. I will set this division up. Okay, and how much did you apply? You were applying 30 newtons of force, so we're simply going to take that 75 newtons and divide by 30, and that will give you 2.5. Now notice the newtons cancel out in the problem, so there are no units, and again I mentioned this during class, there are no units for mechanical advantage. Again, we move down to number 2. Again, we have a bottle opener. Again, the bottle opener is being used as a lever. And we'll talk more about these simple machines later on. So again, since we're finding mechanical advantage, what is the force we get out of the lever? How much force did we have to apply to the lever? In this case, we are applying 55 newtons of force, and the bottle opener will multiply that to 675 newtons and apply that to the cap. Okay, so our top number here is going to be 675 newtons. And we're going to divide how hard we pushed on the lever. Okay, and as you can see there in the problem, and then as I just mentioned there, we are applying 55 newtons of force. So again, very simple division problem, 675 divided by 5. You'll get 12.27, so we're just going to round that up to 3, so 12.3. Okay, let's keep moving through this. We are on number 3. The back of the truck weighs 240 newton. What's the mechanical of the branch that you're using as a lever if you apply 600 newtons of force? Okay, so we got to take the weight of the truck's rear end and divide how hard we have to push down on that lever along with your passenger. You two are going to push down with 600 newtons of force, and I believe 2400 divided by 6 is a mechanical advantage of 4. Again, still using the same thing. Mechanical advantage is force out over force in. Okay, in other words, what does Tom apply and what does the crank apply? The crank, it shows there in the problem, applies 60 newtons of force. And that 60 newtons of force is the result of of Tom applying 20 newtons of force. So obviously 60 divided by 20 is a mechanical advantage of 3. Now we get down to number 5 here, things change a little bit because we're no longer finding the mechanical energy. We are told that the mechanical advantage of the nutcracker is 3.5. So what is the force the nutcracker applies to the walnut? So what we are actually finding is the force out. Now, again, using basic algebra, we can rearrange our equation to find force out. Okay, if we take and move the force in up here by mechanical advantage, that gives us force out. So force out is the MA, in this case 3.5, simply multiplied by the amount of force that we are applying to it. In this particular problem, 75 newtons is applied to the nutcracker, so we're simply going to multiply that. 3.5 times 75, and 3.5 times 75 happens to be 262.5 newtons. Now, in this case, we do have to have a unit of measurement because we're finding force. 3.5, this newton is not canceled out, so it continues on and becomes the unit in your answer. Okay, let's move to the second 5 problems on the next page. I'm going to scroll here to 6. In 6, we're again finding something other than mechanical advantage. What is the force applied to the lever? So that would be your force in. To apply force in, you simply take the force that you get out of the machine, in this case the lever, and divide that by its mechanical advantage. Our mechanical advantage is 4. The lever puts out 800 newtons of force, so 800 newtons goes on top. Our mechanical advantage of 4 goes on the bottom. We set this up as a division, and that is going to be 200 newtons. So you would have to use 200 newtons in order to move that rock. That weighs 800 newtons. Again, if we read through here how much force is applied to the lever, again, that's a force in problem, so we're doing exactly the same type of problem here. So we read through our problem, and we see that the lever is doing 1800 newtons of force. And you have a mechanical advantage of 6. So we set up the division problem, 1800 divided by 6. That's going to give us 300 newtons of force being put in to the lever. Number 8, how much force does the pulley apply? So again, this becomes a force out because what is the machine doing? So we work through this problem, and we find our mechanical advantage. If we read through the machine, it says the mechanical advantage is 1.5. And the force out that we are getting, or excuse me, the force in applied by the worker was 250 newtons. So again, we're simply doing a simple multiplication problem. And you will get, for number 8, exactly 375 newtons coming out of the pulley. Okay, as we continue, again, we get back to what is the mechanical advantage. So we're back to our force out over force in. So it says here the nutcracker applies 50 newtons of force. That is what the machine is doing for us. Okay, if we come down then, how much did we put in? We put in 15 newtons of force for that. So we are simply going to take 50, divide that by 15. And our answer here is 3.33. Since we're going to the tenths, we'll just say it gives us a mechanical advantage of 3.3. Then we get to our very last problem. How much force must the mover use? So how much, if you are the mover, will you be putting into the machine? Okay, again, we've done these earlier. We know that's force out over mechanical advantage. We're going to lift a piano of 1,450 newtons, so we got to apply at least that much force. And the mechanical advantage of the pulley that we set up as a mechanical advantage here of 10. That's quite a pulley system if it has a mechanical advantage of 10. And if we take that, we are going to get 145 newtons. So you would have to pull on the rope of the lever with a force of 145 newtons. So just a quick overview of what we talked about in class and doing actual mechanical advantage as opposed to ideal mechanical advantage. Okay, as you move on to the PowerPoint, we're going to start talking about the 6 types of simple machines and how to calculate.
Cravens, please come back to the front office. Michaela Cravens, please come back up to the front office.
Again, we will be learning about what is called ideal mechanical advantage. What would these machines do under perfect conditions with no friction? So, please watch, go through the PowerPoint, watch the video that follows that shows you and talks about these 6 different, and then I hope and wish all of you have a wonderful Thanksgiving break.